Has Python's memory model ever felt like, I don't know, a bit of black magic? Well, this explainer is for you. We are going to completely change how you see Python variables. And trust me, this is a concept that is absolutely critical for async coding interviews and for squashing some of those really tricky bugs.
Let that just sink in for a second. This one single idea, it is the key to everything. Once you truly get this, I promise, Python is going to make so much more sense. So let's dive right in. We're going to start by tearing down a common, flawed mental model that, let's be honest, most of us were taught. And we're going to replace it with the simple truth of how Python actually works under the hood. Okay, so here's the big lie, that a variable is like a box, and you put a value inside that box. Nope. The truth is actually way cooler. A variable in Python is just a name tag. It's a label or a pointer that simply points to where the real data lives in memory. It doesn't contain anything at all. To make this super concrete, we're going to use an analogy for this whole explainer. I want you to think of a variable as just a simple name tag. The object, the actual data like a number or a list, that's a toy. And memory, that's the giant warehouse where all of these toys are stored. So look at this. When you write x equals 10, Python doesn't put the number 10 times inside some box called x. No way. Instead, it creates a little toy object for the number 10, puts it somewhere in the warehouse, and then just attaches the name tag x to it. And that ID function, that's our little trick to see the object's unique memory address, its exact location on the warehouse shelf. And this really is the core concept. The variable x doesn't hold the number 10, it just holds the directions on how to find it. This is also why passing variables around in Python is so fast. You're just handing over a light little set of directions, not some heavy, clunky object. Okay, so if variables are just name tags, what exactly are these objects they're pointing to? And how in the world does Python keep track of it all? Well, that's where Python's amazing filing system comes in.
Here is a fundamental, mind-blowing truth about Python. Everything is an object. Seriously, even a simple number isn't just raw data. It's a full-blown object that comes with a value, a type, and that unique memory ID we talked about. This is so key to Python's power and flexibility. So where do all these variable name tags actually live? They live inside something called a namespace. The easiest way to think about a namespace is like an address book. It's basically just a dictionary that maps each name to its object. And Python's really organized. It uses different address books for different situations, like one for inside a function and another for the main script. And this is why namespaces are so important. When you ask Python for X, it doesn't wander around the entire memory warehouse looking for it. That would be so slow. Instead, it just does a super fast lookup for X in its current address book, the namespace. It's incredibly efficient. All right, now we're getting to the part that often confuses people, but we're gonna make it really simple. Let's talk about the conceptual map of Python's memory, the stack and the heap. And it's really important to remember this is a model, right? It's a way for us to understand the behavior.
I want you to think of it like this. The stack is like a fast, perfectly organized stack of pancakes. It's where Python keeps track of all the variable names and their references, those directions. The heap, on the other hand, that's the big, sprawling warehouse we've been talking about. It's where the actual objects, the real data, are stored. And this slide just shows it perfectly. See? The variable name x, our little name tag, it lives on the fast and organized stack. But it holds a reference, that arrow, that points way over to the big, flexible heap, where the actual list object, our toy, resides. If you remember just one thing from this section, make it this. The stack knows the names. The heap knows the data. Simple as that.
Okay, so understanding the stack and heap sets us up for what is probably the most important part of this entire explainer. Seriously, getting the difference between reassignment and mutation is the absolute key to avoiding some of the most common and frustrating bugs in Python. Reassignment is when you take your name tag and you stick it onto a completely new object. The old object is just left behind. Mutation is totally different. You don't move the name tag at all. Instead, you walk over to the object it's already pointing to, and you change the object itself, right there, in place. And whether you can actually mutate an object all depends on its type. Things like numbers, strings, and tuples are immutable. You can't change them. You can only reassign the variable to a new one. But lists, dictionaries, and sets? Oh yeah, they're mutable. You can change them directly.
And this right here leads to the most critical distinction of all. With mutable objects, you can have multiple variables pointing to and changing the exact same piece of memory. But with immutable objects, any change actually forces Python to create a brand new object. Understanding this will save you so many headaches. Now, let's see how this all plays out in a classic interview problem. This is exactly where a lot of developers get tripped up, but you're about to get the tool that lets you see right through the trap. Look at this really closely. These two lines of code, they look like they do the same thing, right? But what's happening in memory is completely different. The plus operator reassigns B by creating a totally new list. But .append, that mutates the original list right where it is, and that's the trap. If another variable was also pointing to that same list, it would suddenly change, and you might not expect it. And that's exactly why interviewers love this question. It looks like you get the same result, but it reveals whether you truly understand what's happening under the hood. It's not about what you see on the screen, it's about the memory story. So how can you be sure? How can you prove what's really going on? Well, you have a debugging superpower built right into Python, the ID function. If you are ever confused about whether two variables point to the same object, just compare their IDs. If the IDs are the same, they are pointing to the exact same spot in memory. ID is the truth. It never lies. Okay, that was a lot, so let's do a quick power summary. Feel free to screenshot this. A variable is just a reference to an object. The object is the real data sitting on the heap. The stack stores the names or references, and the heap stores the objects. Immutable types create a new object when changed, while mutable types change the same object. And when in doubt, ID is your memory truth detector. And there you have it. That's the simple truth of Python's memory model. If this explainer finally made everything click for you, do me a favor and hit that like button. Subscribe for more deep dives like this, and prove you get it by commenting stack versus heap down below. Thanks so much for watching.